Hey there, I'm Eric Tennant, and today I'm building a 48 volt 20 amp hour 13S Bluetooth solar e-bike battery with active balancer. I'll be using these Samsung 50E 21700 500 milliamps, or basically 5 amp hours, and it puts off 9.8 amp hours of discharge, or roughly around 10 amps. So first we have these little plastic dividers. These are really cool. You can customize and build these into any shape. This will be the shape I'm using. It's 4p 13s. These little pieces come in these little 2 slots like that, and they got notches in them, and it's kind of like good old Legos, I guess. You just push them together and you can make any size battery then. So to give a basic explanation of how the battery works, say one of these is roughly around 10 amps, right? So that's 10 and it's 4.2 fully charged. So we got the 4 here. So now we have 40 amps once these are all connected. And of course, we're using a double-sided nickel strip. It's made for 2p. Real nice stuff there. It's 0.2, it is in the thicker end of it. So that's not good enough. You got basically 40 amps there times 4. You still would not have enough watts. So what you do to increase the voltage then end of that algorithm is we come in and we're gonna go ahead and flip these up. Oh, so we just come in and we flip these upside down. They're gonna go the other way. And that goes that way. Then when the nickel bridges this across like this, that 4.2 suddenly becomes 8.4. To continue that idea on, if you wanted even more voltage, you would add another one. So now you're setting 12 point whatever. That's pretty much the whole basic build. You go back and forth because the nickel strip will be connecting these ones, flipped over on the other side, it'll connect that one. That's pretty much the whole thing there. So I'm gonna populate the cell now just by putting these in here. Prior to this, I did take the multimeter and I checked every single cell in the group. You need to make sure that they're all the same voltage, especially in the PC going this way. If they're not, you're gonna have a rush of power going to one to the other if there's an imbalance, and that wouldn't be good. So yeah, I just basically use the multimeter to basically check the voltage on it. These luckily are new cells, so they all came in perfectly, but yeah, I did check every single one of them. So I'm gonna finish populating this now. Oops, got that one backwards. Just take that part out. So my particular battery, you would do 4.2 times 13, and you get somewhere around 54.6, and that's the full charge for a 48 volt battery. So now that we have the battery all the way populated, we now know one side will be a positive and the other side will be a negative. It doesn't really matter which way, you just got to pick a direction, which one's going to be your 0 position, and then you just go up from there. It'd be like 0, 1, 2, 3, 4, yeah, and so on, which gets into how you connect the balancing wires and all that. So now the next stage is I already made the top one. I'm gonna go ahead and sandwich that guy on there. Now that will keep all the cells separated to a degree so they're never touching, because if these casings are damaged, that is the negative side of both batteries and could cause a problem in the pack. So it is best to have some kind of gaps there. I do have mini packs where they're glued together. I got many of them where if they stagnate in like that, to basically compress them, or they're just without the dividers right up against each other with hot glue. I've never had a problem. I do hear the reports and everything coming out of New York and LA of battery fires. So this is my goal, to make this as safe as possible. All right, so every other one is going to be connected with tape, and of course I will be using the spot welder to do that. First though, I need to cut myself a bunch of strips to be able to have them pre-cut. Whenever you're working with batteries, you want to be very careful with any kind of metal objects around, not to lay it across the pack. It's not so bad now because, well, it's not connected, it's just a series of batteries, but still, it's enough power there to potentially, I guess, burn down the house. So I do actually want one of these little ends coming off for any kind of BMS connection, and that's where they'll be soldering on. Of course, for the positive connection, it will be connected in the middle, and I'll be doubling up the bus bar on it. But for now, I'm just going to make sure I leave the tabbing that I need on it. Yeah, it's not It's not nearly long enough on this side. So just like that. I'm gonna cut these little knobs that they already had on there. Of course, I only need one tab, so I'm gonna remove one of these. And then just because my OCD drives me nuts, I'm gonna take every single corner and round it as best as I can. Just makes me feel better that it doesn't have a sharp edge on it. All right, now I just need to make like 12 more of these. All right, so now what I'm gonna do is I come in and I wanna pre-tin each one of these with a bit of solder. Get it to solder real nice on the nickel. Just come in and give it a little bit of a scratch on each one of the areas. Pre-tin all those. And then these, the same thing there. So once again, later it can be easily attached to the wires. So there we go, a nice little pull. Just gotta do the rest. While I'm waiting for spot welder to charge up, I like to add an extra layer of protection on the top of every single one of the positives by adding these insulated rings. The reason I do that is down in there, this is the positive, but the outside of the case is negative. So once you take away all this layering, there's another plastic ring underneath there. So you can see it there, plastic ring, you got the plastic there. So basically once you're beyond that, there's very, very little space between positive and negative. I like to add these here because if there's any kind of friction, somehow wore that through, this gives that extra layer of protection. The bottom, there's no need. It's all negative all the way up into there. Yep, gotta add all those into real quick. Okay, got my glitter spot welder charged up all the way. Already did my test spot welds. They came in nice for the 0.2 nickel strip. And yeah, definitely make sure you get the real nickel strip. It's not worth cheaping out getting the nickel plated steel. Let's move this a little closer, and yeah, my probes are active here. So I guess this side will end up being negative because, yep. So pretty much just gotta overlay it like that and start spot welding. Okay, so I got my first group and a parallel connection. Now I'm gonna connect those two parallels into series. Nice. So now I just gotta repeat that all the way down the pack. All right, and the next row. That's amazing how much less pure nickel sparks than the plated stuff. Plated stuff's just not worth the few dollars saved, I think. Okay, now that that side's done, I need to flip the whole battery over and do the other side. Of course, making sure that the plating just right. Wouldn't want to cause a loop. That would, I think that's the way you make a heating element. There, so my next one needs to be going onto that way there. Yep, just like that. Double confirm what I'm doing. I don't want to make mistakes here. Not forgiving whatsoever. Okay, yeah. These two are connected on the bottom. So to continue the connection in series, essentially going to connect it like that. So now these three are all connected in series there. And of course, same spot weld the nickel strip on, two of them just like this, and go down there. Okay, now I need to tack weld on the negative plate. It'll consist of two layers. First one is for the BMS, and then this is going to be a bus bar that's going to come over for the wire to be able to connect onto, except it'll be on the second layer, so I'm going to tack weld all this together. Jeez, man. Oh, that was... All right, and for layer 2, and this is the one I already have the solder onto. Okay, so now I have my negative, so that'd be now 0.4, because I tack weld those together with, I don't know, over 100 tack welds. Looks pretty good, actually. So now I got my solder point for my negative wire. Of course, this will be bent over once I get all the paper and everything added. So now I've got to flip it over. And now on this side, I need to do the same thing, but with the positive wire, just like so. All right, and now for the double bus barred layer here with the solder on it, pre-soldered. And now I have the positive terminal. So the next step I'm going to do is I'm going to cut out some of this green sticky back paper. It's pretty commonly used in the batteries. It just helps a nice insulated layer against any kind of shorts, as if the main lead wires or BMS wire shorted out. So yep, I just gotta cut a bunch to length now. And basically I'm just gonna wrap the battery all the way around, starting with the sides first, and then I'll bend the tabs over just to keep everything safe for any kind of solder drops or anything like that while I'm working on it. Yep. And now that I got the paper on, I'm gonna go ahead and bend my tabs over. All right, I already marked the negative and positive for the battery because I'll be covering up the terminals, won't be quite as obvious then. Pretty much layer paper on this side and a layer paper on the other side. Just like that. Could definitely cut a little straighter with my scissors there. I missed a whole corner over here. Oh, that's too long. And now the other side. And then I cover up a good part of the bus, except for where I'll be adding the wire onto there. All right, nice. And this is to insulate the battery from any kind of cold or anything. And it also protects the battery from any kind of short outs. Because each one of the BMS wires is of course going to be laying across going to the BMS. So if there's any kind of problem and that's shorted into the plastic battery casing, yeah, you could have a thermal runaway at that point. I'm gonna go ahead and check the voltage. So this would be position 0 here, this would be position 1. So 0 and 1. All right, so I got 3.5. So I'm gonna start going up now just to make sure they're accumulating. 7 and 45 volts. Okay, so yeah, it's a little under halfway dead, which is fine, that's good. So I'm gonna go ahead and mark all these just to keep track of them. Maybe not, my pen's going out. Whatever, okay. So the next trick is I need to find where I'm gonna basically position my BMS and run all of said balance wires to it. So I got my negative there. I definitely want to be able to connect directly into that with my, with the blue wire there that goes to the battery. So may go there. I don't know. Ugh. Okay, so I'm pretty happy about positioning the BMS right about there. I'll connect it there, and then all the wires will run up and over and to the appropriate connectors there. So I'm gonna set the BMS in place just so I have a good reference of where it is using this 3M double back sticky tape. I guess it's all right. Tried to use it for other things that didn't hold so well, so I'm gonna try for this. Hopefully it'll do better. Probably need 2 or 3 strips of that. So pretty much right about there. Come on, 3M tape. Fail me. Nice, works good for this. So that wire, the blue wire would wrap around there, would connect to the negative, and then this would be the negative wire, and then the positive comes right off the battery. So now I just need to worry about all the BMS leads essentially. Boom. Now to keep the wires really clean and try to keep them from crossing over each other just for another layer of safety, even though it's gonna happen somewhat. I got this double-sided thermal tape. Should make some really nice wire tracks. Should probably another layer of it there just to guide everybody. Yeah. So of course I'm gonna start with the negative wire and lead it back all the way to the negative lead. But yeah, this is what I was talking about. You definitely end up with a bit of crossover if you like it or not. Maybe I can write a different way with that one. You continued. Oh, it's not bad. Probably go with another layer here just to keep everything guided real nice so it doesn't get out of order. Now I can guide that number 0 or negative wire all the way back down to where it belongs there. So pretty much I'm gonna route everything, get them ready, and then I'll chop them short and place them in when I need to do that. And pretty much you do this just starting by that black wire, and then you just very carefully find the next wire. You gotta take easy care, make sure you don't wire it in the wrong order. The BMSs definitely do not take kindly to that. And then you go back and forth, so that was the negative. So that'd be the first black, and then that'd be blue 1, blue 2, blue 3, blue 4, blue 5, blue 6, blue 7, blue 8, blue 8, and so on. Today on Sesame Street. Pretty much. All right, just like that. And then this battery also likes to run a positive wire, which would go back to this one here. I go ahead and route the wire for that, just like so. Then of course this BMS is for pretty much just about any size battery, so it has extra wires coming off of it. What I'm gonna do there is, later I may salvage this BMS for say a later project. So first off, I'm gonna cut them all even like that. So pretty much none of the wires are exposed, and then I'm gonna run tape over the end of it, and then they'll be stored up in the top of the battery, just kind of wrapped up in there. Something like that. Okay, before I go to try to hook any of this up, I'm gonna go ahead and disconnect the BMS wires from the top here just because you don't want those plugged in while you're doing that. You want to test all your leads once you got them hooked up to make sure that it's proper, so you don't fry the BMS. It is a $60 BMS. It's a really cool BMS, actually. It has all kinds of crazy little features with it. Has a heat pad that can go into it. A display screen could be added to the outside of it. It'll connect into a computer, all this crazy stuff. One of the reasons I got it for was the active balancing. Before, I was adding extra wires to each one. I feel like this is a much safer design, and this BMS will be able to do the job of the active balancer. It's only 1 amp, but it's always on the battery, so pretty easy to take care of that. Other safety features like 2 temperature sensors instead of 1. It's just overall, I believe, a much better BMS. The Bluetooth is definitely an awesome feature to it, being able to go in and tell it to active balance. Not gonna lie, it saves me time on the battery build, not having to add the knee wires in, and yeah. So pretty much the next step now that I want to do is, first I want to turn the battery to a better position for soldering, just like so. And I want to start shortening all these wires to where they need to go to. This is definitely where you hope you have all the wires in the right location, or you splice some wires together. Yep. So for this, I'll be using, of course, my good old wire strippers. See if I can short out the battery with them. Full of jokes. Okay, I think I need to get some wire clippers. That would probably help. Just strip it and clip it. Or needle nose pliers. I guess that works too. Maybe. There we go. All right, time to cook my steak. I just gotta strip the end and solder them all to there. All right, I preloaded each one of the connections with a heat shrink, and that'll be used to cover up the little bit of tab. Just another layer of security there. So pretty much just gotta solder on quite a bit of connections. 15 connections? I don't know. 13 of these, the balance wires, I know that much. So there's one. So essentially just do it like that, and then I pull my heat shrink back over here, and I just try to essentially just push it on that tab as far as I can get it. At that point, I want to do the heat shrink. There's no way in heck. I've learned my lesson in the past, and pointing heat comes out of the battery, so it's much better to use a Bic lighter or a torch lighter or something, and be able to have control of where you're directing the heat to. Nice, just like that. And so now I need to do that for all the other connections. All right, and next. Okay, I got them all soldered, except the positive wire over there. I need to look up to see if I add that plus this, or just this wire. I'm too sure with this particular one, so yeah, the manual's on the line. So now I just gotta push on all my heat shrinks and fire them to size. Nice. Oh no, there went all my heat shrinks. Dang it, I'm gonna have to pick that up. Shit. Okay, moving on. So here I got to connect the balance wire and the positive cable here. So I could also connect the positive over to the positive bus over here. Actually, that's maybe the direction I'm going to go, because once this is on, it's really kind of a pain in the butt to solder multiple wires. And I still need to length this one, so I'm going to finish this one off as a balance, and then, yeah, I'll tack this positive wire over to the main lead. Okay, now that I have the BMS connected, I need to go through and confirm all the voltage across all the pins, and I make sure it adds up, so it'll be around 3 and then 7 and so on. If the voltage is out of order, I know one of my wires is bad and I need to go back through all of it, which would be no fun. So let's hope that's not. So pretty simple to do this. You get the whole harness out right here, and you're going to want to start at the negative. On the sides of these clips, there's little holes where you can push the probes into. So we got 3.14, 7, I take my glasses off. 17.6, 21, 24, 28, 31. Okay, so yeah, the last one is the 45.8, which would be right because the other wires are the spare wires. So this is good to connect in, because all those wires have been confirmed to be exactly where they're supposed to be. So I'm going to go ahead and plug the BMS in. So now I need to do that positive wire that I assume it boots up the whole BMS. So I'm going to link that in. That just clips right here in the B positive port, which I'll just bring over and connect right into here. So clip it, strip it, twist it. So that's that wire. While I'm here, I definitely need a positive wire on the whole pack. This is a positive side here because I know, I wrote a big old plus on it. I'm going to come in and give this a bit of a tinning. And this is a 10 gauge wire, more than appropriate for this. Okay, now I just need to attach this big old thing. Okay, I'm definitely satisfied with that now. It's got a nice solid connection, no cold welds going on. Nice. I now have my positive battery lead, which I'll make sure I know where the end is now. Now on this side, I need to connect this blue cable here, which they definitely pretended. Unfortunately, that's a damn short as heck there. I need more wire than that, I think. I don't have to send that in. That is nice. So blue goes to the battery, so all the negative energy goes to the BMS as a switch, and then that's the negative cable coming out this way, which obviously I'll probably extend that. Oh, just flick solder clear across the room. Ouch. Okay, that is not good enough. This is just pretty much a heat resisting type tape here, where the double-sided one is actually a thermal one used to sink down, like a heat sink to the back of like a LED, or I would suppose even a CPU. I'm not sure if it would be the most efficient there. So I thought it would be pretty good to deal with any kind of thermal issues and help distribute the heat from the wires maybe. Makes a really good wire guide to guide all the wires throughout the battery pack. I do know that. So I gotta work on this connection a little bit more. That's why I taped it down, is wiring this gauge wire, 10 gauge. Yeah, I don't have enough wattage on my soldering iron, I think. So it definitely takes a little bit to get the whole mess of everything heated up. That's looking better. I'm definitely happy with that connection now. That is a good connection. So now, I think the battery is live, to tell you the truth. Let's see if it may not be putting off anything yet, because I never put the temperature for it. Let's see what we get here. Yeah, getting like 5 volts. Okay, so definitely got to hook in the temperature probes. Oh, we got a power light on the BMS. So definitely know it is active at the moment. But yeah, she's not putting off a charge because temperature probe's not in. Just got to figure out where these plug in exactly to. Okay, did end up figuring out which port. I needed to plug it into the NTC-A port, and that runs the 2 temperature probes off that one. So now I've already tested the voltage on it, so now I need to hook up a XT60 connector to the end to start giving it a charge. So yeah, pretty much just gonna solder on one of these guys here. A little tip for whenever you're soldering these. Put the other side on, keep you from melting your pole. Made sure as I'm soldering this, I disconnected the power from the BMS, and that disabled the power from the 2 wires, making it much safer to solder these two. And I like to put a little bit of silicone right in between the connectors before I put the little lid on. Just keep from any water getting in between there, shorten anything out. Makes me feel better. Nice. Now I have my end connector. So now, well, I definitely need to come by and plug the BMS back in. It's positive power cable there, and bam! Now I have a working battery. Go ahead and use my probe to test what's coming out the end here. 45.9, so it's in about 50%. I'm gonna go ahead and charge it up now. All right, plug in the charger into the wall first before the battery, and this helps prevent any kind of arc by equaling out the 2 voltages on each side. Had some guy sit there and argue with me back and forth on YouTube. Forgot what his channel was. It's bigger than mine, whatever. He's telling me it was the other way around because that's what his manual said. I don't know, I guess he wasn't taking my 5 years of experience as anything. Pretty much the way you know is you'll see your ends will start getting real black from a pop each time. You notice with this, absolutely no pop whatsoever. The voltage was equalized, so there was no rush. Anyways, it's just kind of funny. I'm gonna go ahead and let this charge up overnight, and then I'm gonna come back to it and we're gonna show you guys how cool this BMS is in the inside. Okay, the battery's been charging all night now, so I'm gonna bring up the app on my Android here. So go into local monitoring, and there at the bottom there I can see the GHB, which bunch of numbers. There she is. Nice. And she is at 100% charge, 55 volts. I ended up playing with that earlier. It was a little bit under. I can set the max voltage. I'm not too sure why it went so high. I actually got it here under the parameter settings once that loads up. Got that at 54.60. So not too sure why that's reading higher there. That's interesting. So all these are settable. You got your single cell voltage, high protection that you can set, and then down where it says here where the sum voltage high, I don't know why they got it to where you can set it, because that's not settable. Anything you put in there, it won't allow you. So when you change that, it'll change the total sum. Same thing with the single cell low voltage. Whatever you put in that slot changes the low. It took me forever to figure that out. It was driving me nuts. We got a different pressure alarm. I would assume that's a different in voltage. I'm not too sure what they put different in pressure. And then we got charge over volt protection, which is actually really nice here. So I put that at 10 amps to be about 2.5 per battery, which is about 25% of their output roughly. So they can put out about 10 amps per battery. So I've ended up putting 38. It'll probably never get there. Usually you probably have a discharge around 30 amps, somewhere about with a 48 volt, somewhere about 1500 watts. So. And then of course, this is the really awesome part here. I don't know why it asked me to determine if I have an active balancer every time, but whatever. As it gets into the active balancing, balance current 10. So balance current, it gets to 1 amp. So I can lower that. That's of course the maximum setting. Battery strings, which that it automatically set. That was impressive. Discharge temperature, sleep time. That's when the battery gets bored of you not being in the Bluetooth app. You have to plug it back in to either a charge, something that's going to charge it up if it can take a charge, or some kind of drain. Not much. I did a little USB to my camera and it worked out fine. Balance different open voltage. That's basically when it's going to start to balance the battery. It's going to wait till it's that much out. I can set it to a lower value if I wanted to balance perfectly, but I think that's fine there. To start balancing, and then where's the cutoff voltage, which that I left that as zeros, because I think that means it can just balance at any voltage then, I would assume. So I do know this works. I did see it balancing earlier when I first plugged it in. And then of course, the main page, which this is really pretty cool here. You can see your state of charge, your voltage, your current, and that'll be in or out. It'll tell you on that. You also got kilowatts down here. With that, it'll show you how many kilowatts you're using. I wish it would actually put that in watts, but whatever, that's fine. How many cycles the battery's gone through, that's really cool. Remaining capacity. Fortunately, yeah, it's actually a 20 amp battery. I'm not too sure how to change that. No idea. I wish I did know. Maybe it'll enter a discharge. For the first time, it'll figure out that it's not a 40 amp. I'm not too sure how to do that. May have to plug it into a computer, because you got all the different connections. I think the UART or something like that will go into that, or one of the CAN or something like that. I really wish it was on the Bluetooth app, because this makes life a lot easier here. I can see the 2 temperature probes, which I got one down here in the battery by the positive discharge cable, and then there's another one sitting just right here, which will kind of take the ambient temperature of the pack. And yeah, that's pretty much it. Battery serial number. That's interesting. Yeah, I didn't assign any of that. That's nice. So I like this. I like this a lot. This first is my old solar batteries. Now I no longer have to put in that extra balance leads, which this is definitely safer, having just the single leads. None of them are touching near each other. Everything's separated out real good. Now, one of the last things I need to do is I got these plastic sheets, and this is going to be its outer shell. A lot of times I do see people just wrap them straight like this, but that blue shrink wrap, it's no kind of armor whatsoever. If anything, kind of like a branch or anything went to stab it, it could easily rip through that and cause issues. Once again, I'm just trying to make it as safe as possible, and of course the highest quality I can come up with, using all the highest grade materials I can possibly find. This is a type of ABS, so it's definitely got good stuff. For me to mount this, basically I need to make the shell on it. So I need a place to bend it. First of all, I need to know exactly where to bend it, so I'm going to use tape as a quick reference. Now that I got that marked out, I come in here and I find a straight edge on a piece of aluminum I already have. It's gonna pretty much match that up to the blue tape. Take a razor knife and I just squirt along the side here, and this gives it enough to be able to bend around, and I don't have to tape that corner. Then I wasn't gonna cut them all the way through, and then I thought, oh, why don't I just bend it over, and it's already connected. So a little bit of a knife dripped on that one. That sucked. Okay. All right, something like that. Probably not the straightest thing in the world, but there we go. Straighten that part out right there. Should serve the purpose. Same thing on the other side. I need to kind of complete the cut there. Bam. All right, now I can fold this over just like so. Nice. So basically it would go on just like that. So I'm gonna fill in these voids, so on the top surface there's not giant hollows, more or less, but I wanted something that didn't take any kind of weight. This is perfect foam. All right, so yeah, that one goes there. This one goes over here. I'll add some sticky tape down. A little bit of the sticky tape, and voila. Nice. The joys of picking the backing off this stuff. Now, of course, I'm gonna need a line of sticky tape across that. It's probably good. Oh, now the joys of peeling the backing off again. I got it. Yeah, it's kind of, I'm about to get in the back end of that stuff. All right, now I just gotta put on the cover. Nice. I just gotta do the other side. Okay, now I got that fourth side on. And yeah, a little bit of overlap there I'm gonna have to cut off. Of course, I'll do that. Worry about shorting the battery out as much because I got the ABS in between. I'm not sure if I got close enough there. I kind of got the same thing going on here, a little bit of a lip because of the negative wire. So I'm gonna build up a bit of a foam lip for it to sit onto. Got a little spot for the power cord there. Of course, that's gonna be too wide too, but give me the rough idea. And of course, none of this has to be 100% perfect because there will be a shrink wrap put around the outside of it. I mean, do want to get it as good as I can, but definitely keeping that in mind. Nice. Now I just got to do the other end and trim them down. Definitely going to get my X-Acto knife in here and clean everything up. Yep, just trying to fiddle the corners real nice to pretty them up. Nice. Pretty happy with that now that I made a small mess on the table. Now I'm going to tape all the open corners. I'm going to use the thermal tape once again, but I'm not going to take the sticky back off of it because that would make it a nightmare to try to get the heat shrink over later. But yeah, this should work real nice with the backing on it. Oh, no mic. Nice. Got all the corners taped up. It's all wrapped up in the ABS. So now I'm gonna wrap it up in heat shrink. I got my last piece here. Hopefully it's long enough because that's the length I have. Yep, should be fine because ABS makes the end covers. Easiest way I found to do this is kind of bring the battery to the end of the table. And then you can just slide it right on. Get it about center like. Hopefully that'll shrink up. A little baggy, I'm not gonna lie. Oh, let's remove the other battery from the scene. Get out of the scene, battery. And this is the one time it is okay to point the heat gun at the battery. Now that all that ABS and tape and everything is in between the heat and the heat gun. It's cut through here somehow. Fucking sweet. I'm very happy the way this turned out. This is by far the most advanced solar battery I've ever built. I've used all the knowledge of all the rebuilds I've done, and I think all the repairs I've done, pretty much do the best I can as far as safety and quality and definitely reliability. That's an active BMS in there. The passive BMSs, I'm telling you, once your battery gets a few years old, you're gonna find that they don't charge up all the way. So an active BMS built into this battery is awesome. There's also features on it because I do hook up multiple batteries in parallel. That's cool. Once I have, I guess, multiple of those type BMSs, they'll be able to govern the whole system. And yeah, very, very, very advanced solar battery here. I got all the parts for this down in the description below. Compared to when you buy, it actually did come out not too bad. I think probably about 350, maybe a little bit more. Which is nice for quality cells, quality BMS, everything safely built into the thing. Yeah, this is an awesome battery. I look to get many, many years, hopefully 5+ years out of this one. So here I got my last 20 amp battery that I bought and converted into a solar battery. You can see the extra connection there. I got a gear scale here. It's Gonna weigh in the difference of these because, well, anybody that watches me knows that I kind of broke my burly trailer. So taking weight off of the whole touring thing will definitely be a plus. So let's put this in here. We're on pounds. Good. I'm gonna hook it up to the fish scale here, and let's see what the old one weighs. So we, man, it's hard to keep steady to get it to. I'm gonna go with 12.3 pounds on that one. All right, let's put the new one in, which I definitely can already tell that's lighter. This one we have roughly about 9.5. So we're looking at almost 3 to 4 pounds weight savings right there, just on the battery. Which that's awesome. That's from upgrading from the 18650s into the 21700s. You just get automatic 25% savings in your weight, which is awesome. Carrying around bricks can be a pain in the butt. Thanks for watching. Until next time, you'll see me. Okay, yeah, just add it in. Just cut it in. Sorry, in before everything ends. Where's my scale? Scale. There it is. Oh, has it been 20 minutes already? Jeez. Oh, time goes by when you're working. All right, I need the books. Still recording? Yes, I am. Okay, let's just finish that up.